Okay, good morning everyone. Welcome to this my YouTube channel. My name is Baragem Baradu. Thank you very much for being part of us today. And if you are new here, please kindly subscribe to this YouTube channel and like the video, share it to your friends, and then take note of everything you are going to learn today. Actually, today we are looking at limit, how to solve question on limit. So the first one we are looking at is the limit of rational function. How we go to solve question on limit of a rational function? Let's look at example 1. They say that we should evaluate lim x square minus 4 all over x minus 2 as x tend to 2. How we going to evaluate this thing? Number 1, let's use by direct substitution. Lim, f, lim x square minus 4 all over x minus 2 as x tend to 2. If you use direct substitution, anywhere you see x, you put what? 2. So by direct substitution, we see that here we have x square. So because of this x now, we substitute what? 2. That's why I put 2 in this bracket in place of this x. Then it become 2 raised to the power of square, which 2 raised to the power of 2 rather, minus 4 all over. You see that in the denominator aspect of it, we have x. So we substitute by 2, and we have all over 2 minus 2. So 2 raised to the power of 2 is what? Is 4. Minus 4. 2 minus 2 is what? 0. That's why I have 4 minus 4 all over 0. And 4 minus 4 is what? 0. All over what? 0 also. So the answer here is 0. And this is not the right answer we are looking at, because f of x in this place does not exist in this limit of this function. So because of that, we use the method of what? Factorization. Don't leave your answer like this, if not you will get wrong in the exam. So you use another method, which is method of what? Factorization method. You see that we have limit of x square minus 4 all over x minus 2 as x tend to 2. So how are we going to do it? We use, you know that x square now minus 4 is a difference of 2 square. It's a difference of 2 square, and this is the same thing as x minus 2. When you factorize it, x minus 2 times x plus 2 is the same thing as x square minus 4. So in this case now, all over x minus 2, you see that there's something common between the numerator and the denominator, which is x minus 2. So x minus 2 here, x minus 2 we cancel x minus 2 will cancel the x minus 2 in the denominator. So we leave what remain now is, well, x plus 2. That is what remain. So we become limit of x plus 2. So as x now tend to 2, we put the direct you put it now as x tend to 2. Anywhere you see the x now, you put the 2. So we have the limit of x plus 2 now become what? 2 plus 2, which is 4, and this is the final answer. This is the final answer of this question. So don't make mistake and leave your answer here. This is how to solve the limit of a rational function. Now let's look at another one. Let's look at a limit of a transcendental function. Limit of a transcendental function. What does it mean by transcendental function? Transcendental function are function that is not algebraic, are function that do not have algebraic terms. Example, we have a trigonometry function is a transcendental function. Then hyperbolic function is a transcendental function. Logarithmic function is a transcendental function. And exponential function is also a transcendental function. That is how we are going to solve this. Now, let's look at this limit of this function. They say that we should evaluate the limit of sine x all over x. You know that as x tend to 0, how are we going to evaluate this thing? Number 1, we use direct substitution. By direct substitution, you know that anywhere we see x, we substitute what? 0. And as x tend to 0, you see x, anywhere you see x here, we put 0. And we have sine x, so the sign becomes what? Sine 0 all over 0. And sine x is what? Sine x is the same thing as 0. And then 0 all over 0 is what? 0. Since f of x does not exist, and we're not interested to get our answer in this 0 because f of x does not exist, we use Lorentz hospital rule. And this Lorentz hospital rule is all about differentiate both the numerator and the denominator until you get the specific value that will make the question not to be in something like sine x all over 0. That is so not to be a thing that the function divided by 0. So we differentiate until we get the actual value. That's what raised hospital rule is all about. So let's look at how to solve it by raised hospital rule. Now we differentiate, because if we put z as sine as x as 0 in this time, we're going to still get 0. And yeah, if we put 0 here, we're going to get 0. So because we are not interested of getting 0 here, we differentiate both the denominator, the sine x, and the denominator, which is what? X also. So by differentiate sine x and x, let us put the x and the this differential of sine and differential of x here. So when we differentiate sine, we have what? Cos x. And when we differentiate x, we have what? 1. That's why we have the limit become limit of cos x all over 1. And limit of cos x all over 1 now, we now substitute the value because they say as x tends to 0. So anywhere we see x, we have x multiply this cos now. So we put 0 in place of the x as the cos. Cos become cos 0 all over 1. And cos 0 is the same thing as what? 1. So all over what? 1. So 1 all over 1 is what? 1 all over 1 is 1. So the final answer become what? 1. So the limit of sine x all over what? X is as x tends to 0 is 1. So take note of it. Now let's look at the other one. Now let's look at limit of function involving surd. So before we look at this limit of function involving surd, please, if you are not subscribed to this channel, please kindly subscribe to it, and so that you can get more access to this online tutorial. Thank you very much. I really appreciate. And if you are not like the video, can you help us and like the video, share it to your friends on your school group so that other people will also benefit from it. Thank you very much. Now let's look at the limit of function involving surd. The limit of function involving surd. They say that we should evaluate the limit of square root 4 plus x minus 2 all over x as x tends to 0. Solution. By direct substitution, we see that as x tends to 0, anywhere we see x, we put 0. So 4 square root of 4 plus, here was x, so we put 0 here, minus 2 all over the down part, the denominator was x, so we put 0 there. So 4 plus 0 become what? 4. So then we have square root of 4 minus 2 all over 0. And square root of 4 is what? Is 2. So 2 minus 2 is going to give us 0. 0 all over 0 is 0. So we are not interested to get this 0 now because f of x does not exist. So since we are not interested in getting 0 because f of 0 does not exist, then we rationalize the function by multiplying both the denominator and the denominator by the conjugate of the surd. What does it mean by the conjugate of the surd? Let's look at how to evaluate it. I will explain it. The conjugate of the surd. Let's look at. So the limit they give us lim square root of 4 plus x minus 2 all over x as x tends to 0, we multiply by the conjugate. Conjugate of this surd is the opposite of the sign. You see that this place now we have minus, so the conjugate is what? The conjugate is square root of what? 4 plus x plus, instead of minus here we put plus 2. Don't be confused and change this sign plus here. This sign is different from this minus here. This minus, they are different things. This square root covered body 4 plus x, so they are one thing here. So this minus 2 is not under this 2 now, is not under the square root. So that's why this is the conjugate. This sign is the conjugate. So the conjugate of this, the opposite of this minus, what is plus? That's why I have plus here, plus 2. This is the conjugate of the surd. So we multiply square root of 4 plus x minus 2, which was the first one. We multiply by the opposite, the conjugate of this surd, which is 4 plus x plus, instead of minus, the conjugate become what? Plus 2. So we multiply both the denominator here and the denominator. The denominator we have only x here, so we multiply this function, the whole of this function, times this x. So let's look at how to do it. You see that the denominator here, square root of 4 plus x minus 2 times square root of 4 plus x plus 2, they are the same thing except that it's only minus that make the difference. So this minus times plus is the same thing as minus. That's why I have the square root of 4 plus x minus 2 square, because this is two function. It's the same thing as this two function by expansion. So we just square it. Square what? 2. It's the same thing as this. It's This is two function. We put it together. So that is why you see this square root sign. It's a two function inside. So all over x times 4 plus x plus 2. The limit now, in this case, this 2 now, this power 2 will multiply everything in this bracket here. So this power 2 multiply this one, x and 4 square root of 4 plus x minus this is another terms minus 2, because 2 is on its own here, minus 2 raised to the power of 2 to this square, because this square root, this square now is multiply both thing in the bracket, everything in this bracket, you multiply this one, multiply this one. So all over this. Now in this case, this square root sign, this square root sign, this square root sign cancel the square here. It's cancel the square, it's cancel this square. That's why I have what? This cancel the square root. The square root cancel this. This square now cancel the square root. That's why I have 4 plus x. And this square of 2 is what? 4. So all over x bracket square root of 4 plus x plus 2. So in this case now, we have left here this 4 here, we cancel this 4. So we left by x all over x square, x times square root of 4 plus x plus 2. So in this case, x will divide x here. So we are going to left by 1 all over what? Square root. There is invisible 1 here. 1 all over square root of 4 plus x plus 2. So 1 times this denominator is the same thing as this denominator, which is square root of 4 plus x plus 2. So that is why now, this is what we have now. In this case now, we know that as x tends to 0, just substitute this value of 0 in place of x. Anywhere you see x, you put the value of 0. So 1 all over square root of, where you see square root of 4 plus, this is supposed to be x, so we put 0 here because our x tends to 0, then plus 2. So 1 all over 0 plus 4 is what? The same thing as 4, square root of 4 plus 2. So square root of 4 is the same thing as 2 plus this 2. So we're going to left with 1 all over 4. So therefore, the limit of square root of 4 plus x minus 2 all over x as x tends to 0 is 1 all over 4. Thank you very much. Please, if you are not subscribed to this channel, please kindly subscribe to this channel, like this video, so that this channel will also grow. Thank you very much. I really appreciate your fact that the fact that you are here. Please also let your friend know about the channel. Thank you very much. God bless you. I really appreciate. Also connect to this channel every time, because God is going to help us. We are going to post more of more of the thing that will help us in academic, and it's also mathematics aspect of it. God bless you.